Another use for binary integer variables, zeros or ones, is when we do a fixed cost example. And again, a lot of this time it's in a manufacturing setting where we're producing multiple products. So in this case, we're producing 3 different products. I've just been real original with their names: product 1, product 2, and product 3. And we want to know how many of each product to produce. Right? So in this case, we know what the profit per unit is. So for product 1 is 25 bucks, product 2 $28, product 3 $30. And then we have each product must go through 3 different departments, A, B, and C. And we have so many hours available to us in each department. And here we see how long it takes in each department for each product. So product 2 takes 3 hours in department A, whereas it only takes 1 hour in department B. Everything looks like in department C it takes 15 minutes, right? A quarter of an hour. And then we also have some limit on the maximum production that we want to do. So at most we want to do 175 of product 1, 150 of product 2, 140 of product 3. So we need to also know how many hours we have. So we have 450 hours in department A, 350 in department B, and 50 hours in department C. Oh, and by the way, before I can produce product 1, I have to pay a setup cost of $400. A lot of times that's time, as well as the person that's doing the setup, right, changing the machine over. For product 2, if I need to produce that, it's going to cost me $550. And for product 3, $600 for a setup cost. So, how do you want to try to tackle this problem? Well, let's think about this. What we could do, and I'm not saying this is the right way to do it, but a first attempt might be, let's set the thing up and ignore the fixed cost for the setup and maximize the profit per unit, and then take the fixed cost out of that optimal solution and see what happens, right? So let's try to do this in Excel. Let's see if I can find my Excel sheet. Here we go. So again, we're going to have our output down here in row 2. Here we have product 1, product 2, product 3. Right? So this is my output. Make it my pretty blue color I like. Then we're going to have our objective function subject to constraints. We had department A labor hours, department B labor hours, department C labor hours. All right, those were the first 3 constraints that we could come up with. The objective function was 25, 28, and 30, I believe. Let's see if that's right. 25, 28, 30. Perfect. Let's go ahead and make this a little bit prettier. So here's going to be our left-hand side, right-hand side. Labor hours, we need to stay under. All right. So down here on the next slide, we had 450, 350, 50. 450, 350, 50. How do I make sure I stay under that? In department A, we see that product 1 takes 1.5, so it'll be 1.5 times product 1 plus 3 times product 2 plus 2 times product 3. So in this case, we have each row is its own constraint. I already have the constraints written out nice for us here. So 1.5, 3, and 2. 1.5, 3, 2. B is 2, 1, 2.5. And each of those were a quarter, right? 0.25, 0.25, 0.25. All right. And the other thing we have is the maximum that we want to produce for each product. So 175, 150, 140. So max product 1, max product 2, max product 3. So this will be a 1, 0, 0, and less than or equal to, I think it was 175. Right, we're saying 1 times whatever we produce up here has to be less than or equal to 175. Then we have 150, all right, so that's product 2, 150, and the last one was 140. Right? And then to get the left-hand side, we'd use our good friend the sum product function. Take the variables, make them absolute, and then the coefficients for that particular constraint. Leave that relative, and then I can drag that down. Check one of them. Yay. And then our objective function value, again, is a sum product function of our decision variables and our objective function coefficients. And I like to make that blue as well. So I do not have the setup cost in here. So what I'm going to do is I'm going to first try to solve this thing by maximizing profit to all 6 of these structural constraints, and then subtract. So if I decided to produce product 1, I'd subtract out its fixed cost, subtract out product 2's fixed cost if we decide to do anything there, etc. All right, so let's try this. Data, solver, G2, is that the right one? Yes. By changing, I'm maximizing by changing these guys. Subject to the constraints, they're all less than or equal to, so I can do the left-hand side, or the sum products less than or equal to our numbers. Click OK. Make this simplex. I'm going to try to solve it as LP instead of forcing those to be integer, because it would solve faster. So I'm going to try it and see. Okay. Hey, I got whole numbers. Woohoo! All right. So doing it this way, I see I would produce 60 units of product 1, which is under the 175. I would produce 80 units of product 2, which is under the 150. And I'd produce 60 units of product 3, which is under the 140. So I'm staying under that max, so those are all met. And notice that binding constraints are all of the labor hours in each department. So I'm using up all my labor in every department. But this is the maximized profit, but it doesn't take into account any of the fixed cost. So what I'm going to do over here is I'm going to point here, 5540, subtract out. We did product 1, so we have to take out its fixed cost, which was $400. We also have to take out product 2's fixed cost because we produced product 2, $550. We also produced product 3, so we have one more fixed cost to take out, which is $600. So our real profit here, is, let's do orange, why not? And make it bigger. Bam. Our real profit is $3,990. All right. So now the question becomes, is that the proper way to do this? It is not. All right. There's a better way to do this using binary variables. So what we want to do is add in a binary variable for each of the products and attach to that binary variable in the objective function the fixed cost, so that if we decide to produce units, then that fixed cost will come out. So I'm going to stop here on this video, and on the next video I'm going to show you how to add in the binary variables for fixed cost.